Hello, welcome to the fourth module of our class dealing with social data science. In this session, we will talk about selected use cases. That is, we would like to provide a picture about typical data science projects, and therefore we selected 4 different use cases to give you a better idea how a typical data science for social good project looks like. So in summary, we do have 4 projects, whereas all those projects differ in terms of the output. The first project deals with bicycle parking spots in Paris and is a data visualization, an intelligent data visualization, and shows you how exploratory data analysis in combination with intelligent dashboard design might help an organization to derive data-driven decisions. Then the second project, predicting long-term unemployment in Portugal, is a very good example of how tools can be developed in order to help a person who tries to train unemployed people or tries to provide optimal training ideas for long-term unemployed people, and a tool that predicts if a person is in danger or if there's a high probability that this person belongs to long-term unemployment. So here we have basically 2 tools that were developed. Then the third project deals with the COVID-19 mortality surveillance platform. Here we will provide a tool that was developed in order to do the web scraping, in order to collect relevant information during the COVID time. And then the fourth project is a domestic violence data observatory. So again, here we do have a dashboard built on different data sources that were presented. So I will go through all those 4 projects and try to provide more details on the underlying idea of this project, on the technical details that were relevant in order to answer the question that is linked to the project, and I will provide results to show how the results were presented to those people who have to face those challenges. Before I start, I would like to say that this session is the so-called beginner session. That means we will go through the projects from a non-technical perspective. So if you are more interested in the advanced details, so to say, the programming codes and the models that were applied, I would like to refer to the advanced session that is available on our platform. So there you will find a presentation that looks similar to this, but it provides additional information on the programming codes, on the programming libraries, packages that were applied, and on the models itself. So the target group for this presentations are people who are interested in social data science and who are interested in the issues that can be tackled with social data science, and those people who want to be inspired or want to get inspiration about how problems can be solved. So let us start with the first project. The project is located in Paris, and the goal was to support data-driven decision-making with open data. So the project team that is linked to this project are volunteers that were organized as in a correlate chapter. And here, in total, there were 10 people involved, and those people were divided into data and research teams. So there was one team dealing with the research, how to get the data, which data is available, and more important, which data is relevant in order to support the relevant decision. And there was a data team responsible for the technical data processing. The stakeholder or the partner of this project was the City of Paris Mobility Department. So it was located in the public sector. And the problem statement was that the city of Paris, that is currently in the transition to green mobility, has the goal to strengthen the bicycle infrastructure. So in order to provide motivation for the people to use the bicycle instead of the car, the city of Paris was seeking spots where bicycle parking should be available and is not available right now. So the idea was to find parking spots for bicycles. And the background information for this project was that in 2020, there was a plan published by government officials. It's so-called Plan Velo 2021 to 2026. And there was a massive improvement in cycling infrastructure mentioned. So therefore, this project was linked to this published document. And the ultimate goal of this project was to support the green mobility transition by providing a visualization where bicycle parking spots are needed the most. So to structure this problem statement, we provide this structure, and this is also the structure of our platform. And here we do have the organization mentioned, and we see that the organization is correlate. The partner type is the governmental agency, and this project can be summarized as a Sustainable Development Goal 11. This project was a so-called short-term project, so the project itself was categorized as a short-run project. So this means that here the duration was not longer than 4 weeks, and the type of analytics for us is a so-called modeling analytics. And the data that was applied was governmental data. If you're interested in the data, you can click here. We have a hyperlink in our presentation if you're interested in more detail and in a description of the project. So first of all, which data was processed? So based on the research team, the Data Science for Social Good team, so the Correlate crew, had several data sources available from the government, and the data was collected by the government already, so that the certain quality checks already were conducted and did not have to be conducted by the team itself. So therefore, the whole data was publicly available in open data platforms. And what was the data that was processed within the project? First of all, it was the idea about the bicycle parking spaces that were available in Paris. Then, also relevant to the project was the number of visitors at train stations. So to find out who is taking which train to which station. So the assumption here was that people who travel by train have to go to the station either by car or by bus, and also might get the chance to travel by bike if there is a parking spot. Also, the incoming annual traffic volume per station of the rail network was there as a data point, and green spaces and similar all over the city in Paris in order to find spots where parking spaces can be constructed. Also, parking on public roads and parking spaces were also there as a data set. So these were the data provided by governmental institutions, and these were basically the data linked to the working hypothesis of the team. So for each data set, there was a working hypothesis available, and then after the working hypothesis were checked, the data was collected and then combined in order to visualize it. So the methods the technical team used in order to prepare the data for graphical presentation of parking spaces was first the aggregation. So The normal issue if you work with data and have different data sources is the aggregation. So you have to align the data, you have to put all the different data sources into one data set, and this is the so-called data synchronization, which basically is one of the most time-consuming block in a project. So as a rule of thumb for use for your information, normally you should take into account that this time-consuming task costs you 70 or 80% of the full project time in order to get the data and to aggregate it to this point that you can work with the data. So the next thing is the data normalization. That means if you have different data sources, you need to normalize the data in order to process the data with models like neural networks or other models that are linked to machine learning. The same is with data cleansing. So you have to get rid of outliers, or you have to assess the data in terms of missing data. And also what was conducted here was the formation of weighted averages. So if you have different data sources, you might work with averages of different data sources, and then you have to decide on how much you want to weight each data source in order to get a weighted average where each data source has an individual weight. So these are basically technical issues that have to be done if you work with data. So you have to bring the data into a format that you work or might work with the data. So the data sources itself were bicycle parking spots, and this data was already available in the city area and train station. Then there was census data, green spaces, data on green spaces, so the location and size of the parks, public transports, and additionally, in addition to the already discussed data sets, there was a museum data, so to find spots of public interest where tourists come and go, and also a lot of people have interest to travel to. And also there are schools which were relevant for the bicycle parking. So the location of schools was relevant, and the location of shops to find out where people have interest to travel within the city and where they might take the bus, the car, or the train or the metro. So based on these data spots, the visualization was as follows. The team of Correlate came up with a smart data visualization, which is shown here. So this is an overview of the dashboard, the so-called dashboard the Correlate team invented. And what you can see here is you can see the plan of Paris, the city plan. And this plan provides an easy to understand visualization of the city. And here you can decide between demand index, supply index, or a combination of both, demand and supply for bicycles. Yeah. And here you can see the demand in a color. Between 0 is light and the dark blue is scaled here, where you can easily spot the place where there is a demand and supply based on an index, which is the weighted average that was calculated. And the demand metrics can be chosen here. So you can choose by population, museum visitors, metro passengers, train passengers, number of shops, or school capacity. So to say, all the data sets that were incorporated into this dashboard can be selected here individually in order to visualize it on the map. So as a result, what you see here is an intelligent data visualization that provides an easy to understand overview about existing data. So the main benefit from this project was a consolidation of different data sources, and without, let's say, complex statistical models, the density of different parameters can be checked here and gives you an easy access to the data in combination with a city map of Paris. So if you're interested in this project, or if you're interested in the product codes, this data is publicly available, also as the code repository on GitHub. So you can find the links on our platform or in the on the presentation for advanced levels. So here you find more information about the programming code and the technical details if you're inspired by this project or if you want to replicate such a project with different data. So the next project deals with a prediction of long-term unemployment in Portugal. So here we do have a different topic. So it's not about data visualization. It's more about the application of machine learning approaches to social problems. The data team here was the squad from DataScience4Good in Portugal, based in Porto. And also it was connected to the Data Science Knowledge Center in Lisbon, which is located at the Nova University. So here were 3 data scientists working on the project, and they received guidance from a technical mentor and 1 project manager. What you can see here is that the structure of the team is kind of efficient. That means you do have a project manager who understands or who is able to understand the project itself and who is doing the scoping of the project. Then there's a technical mentor who provides the lead for the 3 data scientists, so who provides information if the 3 data scientists who have to work on the project have technical issues. The stakeholder in this context was the Institute of Employment and Vocational Training in Portugal, and the scope of this project was to assist counselors who help job seekers to find jobs. And the partner operates over 80 job centers nationwide, and the counselors help those job seekers by providing training courses and helping them with their job application. The problem statement was that before the project started, counselors were drafting personal action plans by picking from a variety of different interventions which were possible. So for each individual, they were crafting personal action plan. And now the goal was to support this action plan, the drafting of those action plans with data-driven tools. And this solution was twofold. So therefore, the first goal of this solution was to improve the process of the identification of people which are at high risk of becoming long-term unemployed. So this was basically the first tool. So to forecast or to identify people that are in danger of becoming long-term unemployed. And then if a person is identified as a potential long-term employee, there was a development of the action plan. So to say which training courses are helpful for this person. And there was a so-called recommendation system developed, a data-driven recommendation system that helps the job seeker to identify the relevant trainings for an individual personal profile. So in a nutshell, there were 2 different goals here. Here again, you will find a summary in our format to get the most striking characteristics of the project, and the data is also available publicly here at our platform or in the GitHub repository of DataScience4Good Portugal. So the project comprises both internal and external data. First of all, the IEFP provided the team the data on individual persons that were registered as unemployed and who were registered in the programs. And what the data scientist had was a history of 12 years of transactional data with about 3.1 million registered individuals. So here you can see that the data set was quite large, and this was basically this dimension of the training set that determines the methods that should be chosen in order to achieve the goals. External data were demographic information and in general about the regions, and internal additional data were the professional background of each individual, the past history with the organization, and the trainings that were already intended by type and outcomes. Also, the relevant information the data scientists worked on were the job offers each of the individuals received and replied to, and the number of times summoned by the EFP. So these were the relevant parameters the team worked on, and this was the result of the research of the data scientists. So then coming to the two solutions, they can be, from a methodological point of view, summarized into two different categories. So the first tool, so the identification of high-risk individuals for long-term employment, is conducted via classification task. So the 3.1 million person, based on the data set of 3.1 million beneficiaries from this service, a classification tool, a classification model was applied in order to classify people into high risk and low risk for long-term unemployment. This was done by machine learning based on the historical data available. The features, so the explanatory variables that were included in this machine learning tool in order to identify the individuals, were the individual education, the unemployment or employment history, the skill set, so the academic background, and the demographics of the region. As an outcome, there was a tool that was able to proactively identify and label individuals as high-risk individuals for job counseling. So the job counselors could use this tool in order to identify the individuals they had to talk to. The next tool was developed for this recommendation as a recommendation tool. So in order to identify the relevant trainings that should be proposed to the high-risk individuals, a so-called recommender system was developed. So you might know a recommender system from sources like Netflix or Amazon, where you get recommendations based on your past movies that you watched or on your past shopping behavior. And so the same system or similar system with the same idea was developed here. So the objective was to improve the suggested interventions by applying data-driven suggestions. And here again, machine learning was applied. And the target was to predict the success probability of interventions based on the individual client history. And here the explanatory variables that were assessed were the success that was predicted. And this was compared to the average success of a so-called reference group, for instance, by age or by other characteristics. So here, this was basically the ultimate goal, to provide a tool that improves the success in comparison to reference group. So the outcome as a result, if you apply this recommender system, was an error measure to aid counselors in drafting intervention plans, so to present with those interventions that are characterized with a high probability of success. So the solution then was that the project team was able to help the job counselors' performance with these two models based on historical data. So the predictive risk classification helped to identify the clients which were at risk or who were at risk for long-term unemployment, and it was already tested and rolled out in practice. And then based on the feedback of the counselors, it was refined. However, it is still in place. The intervention recommendation was a second model, and based on the past intervention, the predictions were created for each individual. and the personalized recommendations and the metric for a success factor were also handed over to counselors in order to reduce the reliance on the experience alone. So here you also have a tool, and as you talk about forecasts, it is always difficult to evaluate forecasts in reality because you need a proper control group. However, this tool was trained on a historic data set. So for the training scenarios based on the historic data set, the data scientists could show that this model was successful. And therefore, they provided a helpful tool that helped the counselors to identify the relevant recommendations. However, the final recommendation was left to the counselor so that this tool was a supportive tool and not the final recommendation. So based on the first two problems we have, or in contrast to the first two problem statements, we have a different tool here, which was developed during the COVID-19 crisis. And this tool deals with the mortality surveillance platform. So here, again, we have Data Science for Social Good Portugal based in Porto. And we have 3 data scientists that worked on the project. The stakeholder was not available, so the stakeholder was, or there was no public institution that supported the project. The problem was derived from the ongoing COVID crisis. The project took place in Portugal, and the situation that triggered the problem was the pandemic, especially the idea that the data collection, especially at the beginning of the COVID crisis, was kind of heterogeneous individually and was not well presented, especially for data-driven decisions. The data science team tackled the issue to provide a clean data set or a structured data set that researchers can work on. So the initiators of this project noticed the problem that the publicly available data was without structure and without documentation. So the ad hoc data collection was without structure, so no researchers could work on it immediately without spending time-consuming efforts to clean the data set or to put the data set into the right structure. Therefore, the goal of this project was to create a workflow, or in programming language, a programming pipeline that helps to improve the quality of the collected data and to make the data available in an accessible format so that researchers can work on that. So therefore, this project deals with a programming tool that helps to bring a given set of data into a correct format. Again, the detailed informations are here. And if you're interested in more details, you can click here on the link, and then you will be referred to our platform where we present this project amongst others. So the internal and external data that was applied were basically external data, as there was no partner, there was no internal data available. And the external data was the mortality data that was publicly available on SICO EVM, which was a portal that documented the mortality rates in Portugal. And this website was kind of unstructured. It provided multiple tables and graphs, but the data was not or was in a raw format, so it was not readily available and not in a downloadable format. So therefore, the data science team in Portugal came up with the idea of providing a tool to make this data or to transform this data into downloadable format. And this was done by a so-called web scraping. So to make the data usable for visualization or machine learning tasks that we saw in the previous two projects, the data was pre-processed via a pipeline. And The goal was to apply a web scraper or to develop a web scraper, which is basically a tool that is able to get content from a given website and then to take the content from the website to pre-process it via programming codes, via a pre-processing pipeline, and as the output, you get a structured Excel or CSV sheet. So the data was in JSON form and provided by website, and the project team analyzed the structure of the provided data and was developing an automated script to format the data into CSV. The challenge here was, as the ongoing COVID crisis led to an initial data reporting, which was later on changed and improved. Therefore, the web scraping tool had to be dynamic to take certain changes into account. Yeah, especially for this target website, the web scraping had to be that dynamic so that it can be easily adjusted to changes in the target website. So therefore, this was included, and the team did it by improving or by including automated checks on whether the data that should be get from the from the homepage was still being obtained or was in the format that was assumed to be there. So therefore, at the end of the day, the project team was able to create an automated system, and it was able to provide clean data sets or mortality data on a daily basis in order to help the public to derive certain decisions based on recent mortality data at this point in time. The project is available and there's a data repository. So the project as well as the data is publicly available, and the data repository was then a well-documented and comprehensive repository that comprises the historic data on mortality in Portugal from 2014 up to today. Also, the team created a data dictionary that is basically an explanation how the data is stored and in which format the data is available. The code is publicly available. You can check it on our platform. There are the links to all the publicly available codes and data. So the last project I would like to talk about here is on domestic violence data observatory. Here we again do have a visualization and in combination with data collection. So the project team was also the DataScience4Good partner in Portugal, again 3 data scientists, and also this project was derived from a public need, but not in combination with one organization, one specific organization. So the problem statement was that the scope of domestic violence was the most commonly recorded crime in Portugal. And in Portugal, there are a multitude of data sources on this subject. However, there's a lack of easily accessible dashboards and data in simple format. So again, in line with the previous project, here we are dealing with data sources that lack in quality, and there are several data sources, so heterogeneous data sources, which are summarized in one data set. And this data set is formatted within a simple or into a simple format so that people who are interested in this topic get a data set they can easily work with. So therefore, this problem statement is connected to 2 goals. On the one hand, a data repository, so that there is a data repository where you can find all the provided data of domestic violence within one place and within a simple format. And based on this format, there's also a visualization of the data within a dashboard, similar to the Paris example in the first place. So again, here's our detailed information and the link to the platform. So the data sources that were applied here were manifold. So the data was only available in type of documents. So in contrast to the homepage web scraping in the previous project, we do have document files here. So more concretely, we have PDF files. And the aggregation of those files into CSV was manually handled. So the data sources in place were the Portuguese Association for Victim Supports that provided reports on domestic violence. There were a quarterly report on domestic violence provided by the Portuguese government, and there was an annual report on domestic violence provided by the Ministry of Internal Affairs. Also, there were reports on victim support structures. So therefore, the combination of all those documents within one database was the goal. So the aggregation of the data set and then the visualization via dashboard was the second goal. So here is an overview about the solution. So the outcome of this problem was, of course, highly technical. And you can find the technical details in our advanced presentation. However, for those who are only interested in the outcome without technical details, here is the solution. So the solution was similar to the Paris example, a dashboard where you can see the Portugal, parts of Portugal. And what you can see here is each region in Portugal in combination with a number or amount of incidences of domestic violence. And here you can see the colors indicate the incidents. So the darker, the better. So zero incidences, which are for instance, here, and here, and high incidences can be found here in this area. So therefore, this dashboard is the so-called front end of the data sources that were collected and provides an easy to grasp overview about the information that is stored in the folders. If you want to have more information on this prototype, please visit the DSSG Portugal about the project itself. And here you will find a link to the GitHub and a better, maybe better documentation, even better documentation about the project. So additional projects that are also presented at our platform, but not presented now in this class due to time constraints are, for instance, fraud and collusion of international development projects. Here we have to, or would like to refer to DSSGfellowship.org. And this project is also linked with a paper. So if you're interested in paper-based information and not only in programming codes or slides, please check the paper here. Or surveying target groups for interest in a good life for the elderly in rural areas, you can find it at correlate.org. So it's not DSSG, it's Correlate. And here you have DSSG Fellowship, which indicates that this is basically linked to the university. And DSSG-PT provides information about the group of volunteers that provide services all over the year without being linked to any university. And here you do have the identification of courses and optimization of waiting times for veterinary consultations at the veterinary hospital. So here you have 3 different examples, which are from our point of view worth investigating. And if you are interested in even more examples in our platform, we provide several projects that were well documented and publicly available, and we provide the homepage, the contact person for these projects, the location, so the country this project was conducted in, and a link to all the available details as well. So the references of this presentations are presented here, and we see each other in the next session.